So, good morning. My name is Dan Shropshire. I'm the Vice President of Sales and Marketing for our Teledyne Marine Vehicles team. I'm going to give a quick briefing today about Teledyne Technologies, environmental responsibility, and sustainability, and just give a quick update of sort of where we're at on this new mission for us and where we're heading. So, this is corporate responsibility in the sustainability area is obviously a hot topic, but something that we're committed to. But we are just sort of starting out and gathering some new information and determining how Teledyne needs, what we need to do as a larger group, to basically be good stewards. We have over the years purchased a number of companies that have a play in the environmental monitoring area, which I'll show you in just a bit. Show some use cases of areas where what we're doing to help really do measurements of the environment to understand how it's changing. We have a big part of that, and also through our robotics, ways that we're really helping to reduce overall carbon footprint by enabling technologies. So we'll talk a little bit about that too. But this is the overall Teledyne Technologies. It's almost 15,000 person company now with the acquisition of FLIR, which just happened last year. So we have a lot of different capabilities now in this area, which again I'll highlight. So from a corporate standpoint, our goal here, major goal, is going to be to reduce our greenhouse gas emissions by 40% by the year 2040. And I'll show some of those numbers here coming up as well. We have a real commitment to environmental and sustainability, health and safety, our people, community, and human rights and governance is all part of what we're trying to do. So a quote from our Chief Executive Officer is, going forward, we will continue to evaluate our emission reduction goals while at the same time providing tools and technologies to enable environmental science and climatology. So just looking at a few of the areas here that we have for looking at environmental science in particular. NASA satellites currently use a lot of our detectors for looking at greenhouse emissions. And we have a number of different programs that use our image sensors and image detectors. We also have some direct measurements, more atmospheric and water pollutants through some of our companies that do that. And then finally, which is more pertinent to this show, we have our slocum gliders and floats, which do water quality measurements and look at environmental impact studies. So in 2021, Teledyne completed its first global inventory of our greenhouse gas emissions, which was the first time we did that. We hired a company to go out and do a study for us. As I mentioned, we have a goal to reduce our emissions by about 40% by 2040. So that's been a big goal. Just looking at environmental and sustainability area, which is really pertinent to the discussion today. Just give a couple quick examples of things we're doing, which I think hopefully you'll find interesting. So one of the businesses we're in is looking at air quality monitoring on airplane flights, which previously really wasn't being done. So it's become widely available in homes and offices and industrial areas, but there's really nothing for monitoring equipment installed in aircraft today. So there's a wide range of quality events which occur on the cabin and definitely affect the health and comfort of passengers, crew, and lead to canceled flights, unexpected maintenance costs. There's a lot of impacts by unhealthy air. So we developed this system called ACES, which is an environmental monitoring system. It's actually the first FAA certified system that helps monitor airplane cabin quality, specifically designed for this use. And combined with our Teledyne Controls group, which is the group that does a lot with airplane manufacturers and the control side, we've basically merged these systems now so that there's real-time monitoring of air cabin air. If you look at some of the work we've done in the space side of doing external monitoring, this is the easiest way of doing environmental monitoring since it's all remote. It's all remote sensing. We have a number of, again, different detectors where we have installed on different satellite systems that do this. If you look here at the first group of carbon dioxide measuring satellites, we've got the orbiting carbon observatories, including MethaneSat, Geostationary Carbon Observatory, GeoCarb, and carbon plume monitoring through the carbon plume mapper. We also have imaging sensors on the Clario mission, which is a new ESA mission, and the Truth missions is coming up. I have a slide coming up on that as well. So, a lot of effects here. We're also looking at radiation budget. So it's not just carbon mapping, but actually looking at the amount of sunlight that is entering the Earth's atmosphere, absorbed by the Earth and then reflected back. So by looking at the difference between how much we're absorbing and reflecting, you can actually get a good measurement again of how much the Earth is heating. That's a different way of looking at the problem. And then finally, we can actually look at the light from plants, the plant emissions that give some indication as well of greenhouse gas emissions. So some of our other instruments on the EcoStress satellite and the SPG missions are helping to do that. I think it's interesting looking at just one example of that. This is an ESA agency image from the Copernicus Earth Observing Program that shows nitrogen dioxide plumes within the worldwide. You look at a couple spots there and ask the question of, why are there so many emissions in some of these areas you wouldn't expect, especially in Africa? China, quite obvious in the Beijing area. You look at the New York, Chicago area, Los Angeles, certainly European emissions, a lot of that from cars and factories. But in Africa, it's somewhat of a surprise, and even in India and the Nepalese area. So a lot of those emissions come from actually single plants. Specifically, the plant down in South Africa is a large coal burning plant that does not have scrubbers that we have in other industries. So you can see immediately the great amount of NO2 emissions coming from one source. But does go to show you a few things, is that regulations and technology certainly can help to eliminate some of these atmospheric gases. So I think it's a pretty telling story. If you look at the upcoming mission here, this is the Truths satellite, which is being built. It's a traceable radiometry underpinning terrestrial and helio studies mission. So here we know the Earth is heating up, weather events are increasing, fire and flood catastrophes are certainly on the rise. This mission will, for the first time, enable high accuracy traceability of climate data. It's going to allow the creation of a robust space-based top of the atmosphere climate observation system. So the primary goal here is to provide measurements for incoming and outgoing solar radiation, as I mentioned previously, looking at the difference and act as a primary calibration and benchmarking tool for orbital imaging and observation going forward. So it will use shortwave infrared sensors from Teledyne E2V, which is here in the UK, to drive its hyperspectral imaging spectrometer to look at the irradiance spectrum. So it's a pretty good, interesting mission. I talked about this a little bit earlier, but where is our carbon footprint right now? Teledyne just did this full study looking at both the emissions that we have as well as the energy usage. So looking at both, again, how much we're polluting versus how much energy we're consuming. And this is the area, again, where we're looking to do a 40% reduction in the next 18 years. So we have, if you look at the graph on the lower right there, again, it's emissions and energy usage, scope 1, scope 2, and then the reduction. One thing we are doing now, I mentioned in Teledyne DALSA, it's a semiconductor company doing a lot of imaging up in Canada, but our facility in Bromont has invested almost $720,000 in helping to reduce emissions through scrubbing. So we've reduced those by about 43% of the greenhouse gas emissions. And so it's one area we're working on now, just things we're doing internally to try to reduce our own footprint here. Other things that we're doing, this is a picture of our semiconductor factory in Grenoble, France. Here we've got a couple of internal initiatives that are both aimed at helping reduce our emissions, but also on helping people become more aware of their environment and acting within it. So here we have taken innovative steps internally through energy efficiency by installing these heat pumps to basically recover waste and reduce emissions from fossil fuels. So they're ahead of the curve on that, and they're also putting in electric vehicle charging stations, as a lot of people are doing, and looking at solar input. But they've also got about a dozen employees that are looking at harvesting honey out of beehives that they've installed on at the plant, and actually having people who are going out and getting more involved in in the environment and understanding it better and the need of bees and honey, bees, I should say, to generate honey. And they've actually been more successful than some of the local harvesters. So, innovative project there in France of sort of connecting people with their environment. On the water safety side, we've done some things here specifically with the COVID and monitoring waste treatment and water output. Here we've got automatic samplers that are looking at measuring COVID in the water, wastewater, and unlike the 1918 flu pandemic, where symptoms appeared within hours and fatalities occurred within days, COVID can spread undetected for weeks before symptoms occur. So here we're looking at automatic samplers as a way of looking at wastewater samples, again, at appropriate monitoring points. So that's another place where we're helping out in keeping the public safe. So more specifically on the marine front, just talk about some of our technologies that are also doing environmental monitoring and really looking at climate study and climate impact, and the biggest of which here is the Slocum glider. So we've delivered a number of these now to a number of universities and research institutes which are doing global monitoring. They're 1,000-meter depth-rated vehicles. They transact from the surface down to 1,000 meters, doing all sorts of different climatology measurements, but most specifically temperature and pressure at depth. We also have other sensors which we can include that are measuring chemicals and biological sensors. So get a really good feel for what the ocean is doing. And those particular observations then go into climate models, weather models, current models to really look and understand how the ocean is interacting with the atmosphere, and that's really driving a lot of the climate. So it gives us a really good idea of what's happening with these vehicles. We can also use vehicles like this to automate data collection, so reducing the number of ships that we need out on the water, so thus reducing our carbon footprint substantially by using technology and robotics. So automating the data transfer certainly is reducing the need for having additional surface vessels that certainly much more expensive and much more polluting. So here's an example where we have Slocum gliders as a data truck transferring data between ground stations and the surface and getting data back to shore, as opposed to having to, again, worry about having people and ships in the area to do that same work. Another part of our portfolio of technology are our Apex floats. So these are advanced profiling explorers. There's an example of a deep float sitting next to us here at the show, which is on the screen. We have almost 10,000 now of these floats delivered. We have a number of different varieties of these floats, but their primary mission is, again, to characterize the ocean environment. So here, again, we're looking at temperature and pressure at depth. We're also looking at the chemical makeup of the ocean through our BGC floats. So these are biogeochemistry floats, which have dissolved oxygen measurements. They have some with pH measurements, nitrogen measurements. So again, we're getting a really good feel for what the ocean chemistry is from the surface down to about 2,000 meters. Our Deep Apex float can do temperature, oxygen, and pressure all the way down to 6,000 meters. And combining all of this data, again, with weather models and climate models, really helps us understand better how the climate's changing over time and contributing to understanding our impact on the climate much better. We also have our EM Apex floats, which is a microcurrent monitoring unit, which allows us to understand better the current circulations within the oceans, and again, understanding how trash as well as heat is transferred throughout the ocean. We're part of we supply floats for the Global Argo program. There are always 3,000 to 4,000 floats deployed around the world that are doing these measurements. We're proud to be part of that through all of our partners who buy floats from us and contribute to this network. So it's a big part of understanding what's going on. A lot of the data that we see on a day-to-day basis with climate models and understanding how energy is transferred throughout the planet come from these Argo floats. I mentioned this earlier, the biogeochemical floats, again, with our acidification modeling with the pH oxygen nitrate, chlorophyll, and get a good idea of biology within the water. We can look at suspended particles. So there's quite a bit you can do with these floats. And the last technology we'll talk about today that's really continuing to help us reduce carbon footprint as well as monitor the environment's the GAVIA AUV. So I'll just turn the volume down a bit on that. All right, that's very loud, so I'm going to just turn that off. I couldn't do the sound from here. So anyway, but the GAVIA AUV is there's an example of that, and we have a model over here on the stand. But again, it's helping to reduce the need for ships to be out on the ocean by allowing autonomous measuring of the ocean, autonomous monitoring of the ocean through these technologies. Our latest GAVIA AUV is the Sea Raptor here, which is a 6,000 meter rated vehicle, again, capable of doing measurements all the way down to near the bottom of the ocean. And again, reducing the need for surface vessels, which again is a substantial amount of carbon emissions and environmental impact. So we're really happy to be using these vehicles not just for scientific measure or needs, mapping needs, but they really are great for climatology, climate studies, and a lot of times we get a lot of data off of these vehicles that not necessarily intended for those, but the data is still very useful. And through some of our new partners with our JO, Magellan, TerraDepth, they're going to be keeping a lot of this data now in databases that make it much more accessible, much easier to find that sort of information to help with these studies. So that's what I had for you today. I'm certainly proud to be working on some of these issues and excited to be starting our trip down the sustainability path and really looking at how we can be better stewards and make a bigger impact. So thank you.
Teledyne Marine. Everywhere you look.